Hey everyone, welcome to Derivability. We're going to continue our series now on hyperbolic functions. This time we're going to take a look at the derivatives of the 6 hyperbolic functions. Okay, and I think what we're finding, if you've been watching the videos so far, is that a lot of similarities between the circular trig functions and now the hyperbolic functions, or hyperbolic trig functions if you like. Okay, and in terms of some identities, and then last time we took a look at some inverse functions. All right, so anyway, let's proceed. Okay, so there in the very nice typeset formulas are the derivatives denoted by primes of the circular trig functions. Okay, again, if you're interested in the hyperbolic functions, you're probably very familiar with the trig functions and their derivatives, as we've got shown there. Now, to see how it works for the hyperbolic functions, we're going to fall back to the exponential definitions of the hyperbolic sine, sinh, and hyperbolic cosine, or cosh, as we sometimes say. Okay, so let's just get going with it here. So let's suppose we take the derivative of the sinh function. Okay, and just to kind of save on some writing and some time, I'll just denote it like that. Okay, what I'm going to do is I'm going to take the derivative of this exponential version here. So I have 1/2. Okay, e to the x is its own derivative. E to the minus x is its own derivative, but we get a chain rule, -1 coming down there. So when we simplify this, we get 1/2 e to the x, minus minus makes a plus, so we get plus e to the minus x. And you have seen this before, which in fact is our definition for the hyperbolic cosine function. Okay, so without a lot of trouble here, without a lot of mess, what we're finding is that the derivative of the sinh function is the cosh function, okay, which is about as close as you can get to the trig version there. Okay, all right, well, let's continue. Let's now do the derivative of the cosh function, cosh x prime. Okay, once again, I'm going to take its exponential definition here and take the derivative. So I have 1/2 e to the x plus e to the minus x, except we get that chain rule, -1 coming down. Okay, so what we find is that we get 1/2 e to the x minus e to the minus x. Well, that is just exactly our definition of the sinh function. So cosh x prime equals sinh x. Okay, now this is similar to what we have in trig, except in trig we have this minus sign there, but with the hyperbolic functions we don't. Okay, so back in the first video, I believe we noticed with some of the identities that a few of the identities are identical, going from trig to hyperbolic. And then some of them are very similar, but they differ only with a minus sign. Okay, so that's what we're seeing here, is we have a derivative that looks very similar to the trig version, but in this case it's missing a minus sign. All right. Okay, well, hope we're having fun. Let's keep on going here. Now let's consider the hyperbolic tangent function. Okay, now in this case, what I want to do here is I don't want to go back to the exponential definition. I want to remember that a tangent, whether it be circular or hyperbolic, is a sine over a cosine. All right, and what we're going to do now is we're going to use properties of the derivatives of the hyperbolic sine and hyperbolic cosine. All right. So we have a quotient here, so let's use our quotient rule for finding derivatives. Okay, and the denominator is going to be the square of the denominator we're taking the derivative of. Okay, Otherwise, we take the derivative of the numerator, derivative of sinh is cosh, times the denominator, okay, and then minus the numerator, sinh x, times the derivative of the denominator. Derivative of cosh is sinh. Okay. Now this numerator, okay, I will ask you to recall from, if you've watched the first video here, cosh squared minus sinh squared, okay, if you go back to these exponential definitions, is always equal to 1. Okay, so what we have here is 1 over cosh squared x, which is the same thing as hyperbolic secant squared x. Okay, and this is the derivative of the hyperbolic tangent function. Okay, so here we have something which is again very exactly the same, except I just put the h's on there. No negative sign that's introduced on that. Okay, so we've had 2 out of 3 so far, just kind of carry straight over from trig, and then 1 where we had a missing minus sign. Okay, we'll tell you what, let me create a little bit more space, and we'll come back and finish up with the other 3. Okay, we're back now. All right, let's resume with the hyperbolic cosecant function. We want to find its derivative. Well, just like with circular functions, trig functions, that's 1 over the sine function, 1 over the sinh in this case. All right, so let's think of this as the sinh of x to the minus 1 power, and then we want to take the derivative of that. So I'm going to bring out the minus 1, and then I'm going to have sinh x to the minus 2, and then chain rule says I need to take the derivative of the sinh, which is the cosh. Okay. Alrighty. So let's see what else we have here. So minus. Okay. Now I'm going to take one of those sinh and write it in a denominator underneath the cosh, and then I'm going to take the other sinh, which is to the minus 1, and write it as the hyperbolic cosecant. Okay, so what we get here is that hyperbolic cosecant x prime equals minus, okay, the cosh over sinh is going to give me hyperbolic cotangent, and then I have a hyperbolic cosecant there. All right, and let's see how this compares with the circular trigonometric version. Okay, well, again, other than the fact that we're talking about hyperbolic functions, it is the same. We have the minus sign. Okay, so we don't add a minus sign. We're not missing a minus sign. Okay, but we do happen to retain that minus sign. Okay. All right, next let's try the derivative of the hyperbolic secant function. Okay, well, I'm going to think of this as the derivative of 1 over cosh. Okay, well, like we did up here, let's think of that as the reciprocal of cosh x. So the derivative, I'm going to bring out that negative 1, and then I'm going to have cosh x to the minus 2 power. Chain rule says I have to write down the derivative of the cosh, which is the sinh. Okay, very similar to the one we just did. I'm going to take the sinh. I'm going to take one of the coshes that are inverse, put it in the denominator there, write the other one as the sech, the hyperbolic secant. Okay, and what we are getting here is sech x prime equals negative tanh x sech x. Okay. All right. Well, that should look pretty familiar to the trig version, so very similar, except here we actually end up getting a minus sign where we did not in the trigonometric version. Okay. So once again, things are just playing out, almost exactly the same as they would be in the circular trigonometry case. Sometimes you have a negative sign, sometimes you don't. It's details. You just have to remember the details or work through the details. Okay, well, it looks like we're out of space again already. So let me pause the video once again and clear some space and be right back. All right, well, we're back again. And what we're finding here, hyperbolic cotangent of x. And so we could write it as cosh over sinh and proceed using the same technique we did to find the derivative of the hyperbolic tangent. Okay, here I'll just try something a little different, just for something a little different, a little fun, is I'm going to write coth x as 1 over tanh x. Okay, and then just kind of take the derivative of the reciprocal of tanh x. Okay, so once again, that 1 over tanh x is really tanh x to the negative 1 power. So taking the derivative, I get the negative to come down, you might say. And then I have tanh x to the minus 2 power. And then chain rule there says I have to write down the derivative of the tanh function, okay, which is the hyperbolic secant function squared. Okay. All right, so I've got negative, and then my tanh to the minus 2, let me write it this way. Okay, it would be 1 over tanh squared, but that would be the same thing as cosh squared over sinh squared. Okay, and then my sinh squared. Okay, and then my sech squared, right there. Well, that is the reciprocal of the cosh. Okay, so these two guys multiply together to equal 1. Okay, so what I have here is negative, and then 1 over the sinh squared is 1 over, sorry, it's cosecant squared, hyperbolic cosecant. So what I'm getting here is the derivative of hyperbolic cotangent equals minus hyperbolic cosecant squared. Okay, which down here is exactly the same as our trig version. Okay, both containing that minus sign. Okay, all right. Now, of course, what you have now are the ingredients for these individual trig functions. Okay, you can take derivatives of products, of powers, of quotients, just using your calculus rules for product rule, quotient rule, even composition of functions, chain rule. Okay, all right. So this was a little shorter than some of the others, but we just didn't need the time like we did before. We just whacked this one out pretty good. All right. So thanks for stopping by. Thanks for hanging around. I would really appreciate it if you give me a like and subscribe. Share this. Let's grow the channel, and hopefully we can all enjoy doing some math together. Also some physics and engineering from time to time. And like I said, I really appreciate you guys. And we'll see you again for hyperbolic number 4 sometime again soon.